Hey guys, it's Amanda and I wanted to show you guys how to calculate a discharge question. So if you're asked about how to calculate discharge on a stream, these are the steps that you'll take. So the first thing that I always like to do when I'm solving a problem like this is I like to write down the formula that I'm going to be using. And in this case for discharge, it's going to be Q equals VA. And the Q stands for discharge, V stands for volume, and A stands for area. So volume is the amount of water that's being thrown out or spit out of the stream. So let's calculate that. The way that we calculate volume is that we divide the distance by the time. And I've given us those variables right here. So if you want to go ahead and pause the video and solve that for yourself, see if you can do it, then you'd have to watch the rest of the video. So you can pause it right there and check that out. So let's calculate for our volume. So V equals D over T, and that's going to be distance over time. So our answer, it says that it should be in meters cubed per second. So I've actually given you the time in minutes. So let's go ahead and fix that so it's in seconds. So I like to teach my labs the picket fence method. So I'll draw my picket fence like this. I have 3 minutes. So I'm going to put 3 minutes up here. And I want to convert that into seconds so it's in the same thing that our final answer should be in. So I know that 1 minute is going to go on the bottom because I want my minutes to cancel out like that. So it goes on the bottom so they can cross cancel is equal to 60 seconds, right? So it's going to solve like that. So 3 minutes times 60 seconds, we're going to put that in the calculator times 60 seconds, and we'll get 180. So equals 180. And that's going to be seconds, because remember we canceled out our minutes. So 180 seconds is going to be our time. So make sure when you're solving this, whether it be on an exam or a lab, that your time, no matter what it's given in, it should be in context of your answer. And you always want to make sure that you have the same units when we're solving these. So we just got our time, and our time is 180 seconds, so over 180. And it gives us our distance, and it says our distance is 25 meters, so 25 meters. So I've got it set up like that. I have V equals D over T, and then I plugged in my two values that were given in the question. So let's solve that. So 25 divided by 180, and I'm going to get 0.138. So I'm just going to go with 0.14 for that. And my units are going to be meters per second for that first part. Now, I'm going to circle that answer. So I've tried to color code it for you guys. So for V, the V up there in our original formula, we got that value. Now we're going to solve for A because Q equals VA. And that one's a little bit easier because we're just solving for area. And in the question that we looked at in the lab, it said that we had like a square-shaped stream like that. And that, I don't know, I grew up, or I went to undergrad in West Tennessee, so we actually had some streams that were shaped like that because they had been channelized because of urbanization and agriculture. So it is possible, it's just a little bit weird to think about. But to get area, we're going to multiply length times width. So I've given you guys those values. So length is 6 meters and width is 4 meters. So A equals 6 times 4. So 6 meters, I'm going to make sure I put my units times 4 meters. That's going to be 24 meters. And I am going to put a box around that so you can see where I am. Now I'm going to get my other color out, and we're going to plug everything into our original formula, the Q equals VA. So Q equals, and remember Q stands for discharge. Q equals VA. We calculated V to be 0.14 meters per second. I'm going to use some parentheses in here, so 0.14 meters per second. So I have it like that. And we're going to multiply that by the value that we found for A, so 24 meters. And I forgot to tell you guys, since we multiplied meters by meters, it's going to be 24 meters squared for that one. So I'm going to add 24 meters squared. And then I'm going to multiply. So 0.14 times 24 equals 3.36. Now, I multiplied meters squared by meters. So we're going to end up with meters cubed. So meters cubed. And we can't forget this second. So meters cubed per second. So that's how you are going to calculate for discharge of a river. I hope that answered your questions, and good luck on your exam tomorrow, guys, or this week, guys. Bye.